The James Webb Space Telescope has observed a supermassive black hole producing intense bursts of energy, known as black hole fireworks. These eruptions occur when matter is pulled into the black hole, forming a hot accretion disk that emits powerful radiation and jets. Webb's infrared technology provides detailed insights into these high-energy events, advancing our understanding of black holes and their role in shaping galaxies. This discovery helps scientists explore the extreme conditions around black holes and their influence on the universe. For the first time ever, NASA's James Webb Space Telescope just got us front-row tickets to the most intense light show in the Milky Way. Webb just watched as explosive bursts of light blast out from Sagittarius A, star black hole, some lasting mere seconds, others lighting up our galaxy's core for months. You have to stick around until the end because I'm going to show you how these massive cosmic explosions share a surprising connection with something you see in your own backyard hard every single day. Hi friend, welcome to new episode of Lumincrafts. While nothing can escape a black hole once it passes the point of no return, the space around it is actually one of the most violent and energetic places in our universe, and what Webb just observed is absolutely unprecedented. For an entire year, astronomers watched as our galaxy's central black hole put on a light show that never stopped. Not for a day, not for an hour, not even for a minute, but to understand why this discovery is so revolutionary, we first need to zoom in and see exactly what's happening at this cosmic dance floor. Right now, we are sitting about 26,000 light-years away from our galaxy center, that's roughly 153 quadrillion miles. At this almost unfathomable distance there's a black hole, so massive that if we replaced our sun with it, would stretch all the way out to Mercury's orbit. But using Webb's incredible infrared vision, scientists didn't just take a single snapshot, they watched this cosmic giant for 48 hours spread across an entire year. Every single time they looked there was something new happening, 5 to 6 major flares every day. Think of them as cosmic base drops, but between these massive bursts there were countless smaller flickers, like strobe lights in the darkness. So far, our scientists haven't found a pattern in this activity. It appears to be random. So what exactly are we seeing here? These aren't actual visible light shows, they're infrared emissions that Webb can detect, and unlike anything we've seen before, these observations revealed something fascinating about how black holes interact with them surroundings. You see, what Webb discovered isn't just one type of light show, it's more like 3 different performances happening simultaneously, and each one tells us something unique about what's happening around this cosmic monster. First, we have what scientists call the quick flickers. Think of them like cosmic camera flashes. These last for just seconds, popping up randomly like sparks from a campfire. They're the smallest of the bunch, but they're happening constantly. Then there are the showstoppers, massive bright eruptions that happen 5 to 6 times every single day. Imagine that in just one day, our galaxy's black hole puts on half a dozen shows that would make the 4th of July look like a sparkler. But here's where it gets really weird. Behind all these cosmic pyrotechnics, there's a third type of activity, long slow burning changes that surge over months. It's like a slow pulse beneath the chaos, suggesting there's something even more mysterious happening that we don't yet understand. Now, what makes this discovery so revolutionary is that we've never seen this kind of constant activity before. Previous telescopes could only give us glimpses, like trying to watch a fireworks show through a keyhole. But Webb's infrared vision lets us see the whole picture. All this activity is happening in what scientists call the accretion disk, a massive swirling disk of superheated gas and dust that circles the black echo like water circling a drain. But unlike water going down a drain, this material is moving at nearly the speed of light and being heated to temperatures hotter than the surface of the sun. Scientists think they figured out what's causing those 3 different types of flares, and it's all coming down to 2 main processes. Let's start with those quick flickers. They're actually caused by something surprisingly similar to what happens on our sun when you look at the sun through special telescopes. You can see solar flares erupting from its surface. These happen when magnetic fields on the sun get twisted and snap like a rubber band that's been stretched too far. Now imagine that happening with magnetic fields so powerful they can accelerate particles to nearly the speed of light. This process is called magnetic reconnection. And it's like cosmic lightning on asteroids. When these particles get accelerated to incredible speeds, they emit powerful bursts of radiation. That's what Webb is seeing as those bright daily flares. And those mysterious long-term changes, well, that's where we enter the realm of the unknown. Scientists think it might be related to changes and how the material flows into the black hole, like a cosmic river that sometimes runs faster and sometimes slower. But here's where Webb made an even more bizarre discovery, something that nobody expected to see. You see, Webb has this amazing ability to look at two different types of infrared light at the same time. When these flares erupted, the shorter wavelength light would change brightness first, and then a few seconds later, sometimes up to 40 seconds later, the longer wavelength light would follow. Imagine throwing a glowing hot coal into water. It doesn't just go dark instantly, it fades through different colors as it cools. Something similar is happening with these flares. As the energetic particles spiral around magnetic field lines, they're losing energy, but they're losing it faster at shorter wavelengths than at longer ones. But here's the really exciting part. We might just be scratching the surface. The team has proposed something ambitious. They want to point Webb at our galaxy's black hole for 24 uninterrupted hours. Why? Because right now, it's like trying to listen to a whispered conversation. At a rock concert, there's so much noise in the observations that some of the finest details are getting lost. With 24 hours of continuous observation, they could filter out this noise and potentially see things no human has ever seen before. Every massive galaxy we've ever found has a supermassive black hole at its center. They're like the engines of the cosmos, but we never fully understood how they helped shape the galaxies around them. These cosmic light shows we're seeing aren't just pretty fireworks. They're telling us how black holes interact with their surroundings, how they feed, and how they influence everything around them. But perhaps the most exciting part of this discovery is what it tells us about our ability to study the universe. Just a few years ago, seeing these kinds of details was impossible. Now, thanks to Webb, we're watching events unfold around a black hole in almost real time, 4 million times more massive than our Sun, 26,000 light-years away. If you enjoyed this video, please like and comments for more videos like this. Subscribe to this channel. Thank you.